Hello and welcome to Lesson 8-4 on direct variation. In tonight's lesson, you will be able to find the constant of variation, and you will also be able to write a direct variation. So we're going to go ahead and get started. Alright, in last night's lesson, or the other lesson, we talked about slope-intercept form, which was y equals mx plus b. Alright, in tonight's lesson, we talked about direct variation. It's a linear function using just y equals k times x. So really, the only difference between them is, yeah, they change k to m, but this adds at b. But if we got rid of that y-intercept, meaning it always starts at 0 with direct variations, they're the same idea. So the m, or k in this case, the slope of the line, stands for the constant. All right, so it's a constant of variation, meaning whatever it's being multiplied by, the slope. So we're going to go ahead and get started. This table of values model a direct variation. Graph the direct variation and then find the constant. All right, so that's our first job. We need to graph these points to find the constant, or really the slope of the line. So we can go ahead and do that. We know how to graph them. You start with the x-axis. And I'm going to do -2, -1. There we go. Then I have 0, 0, 2, 1, and then 6, 3. Now, in the last night's lesson, or the other lesson, we talked about how to find slope. You can find the change in them. You could do rise over run, whatever. All right, so in this case, we really could do find the rise over run and do from this point to this point, well, I go up 1 over 2. Up 1 over 2, my slope is 1/2. Another way to do it, and they show it in tonight's lesson, is to use this idea of y is equal to k times x, and choose any of these points other than 0. So let's see, I'm going to choose, well, 3, 6. And you can put those numbers in here. So for y, I put in 3. For x, I put in 6. So now I have 3 is equal to k times 6. Well, to simplify or get k by itself, because we want to find what constant is, or the k, you divide by 6, and you have k is equal to 3/6, or 1/2. So our constant of variation here is 1/2. All right, so now that we have that, you can really write it. Y is equal to 1/2 x. A lot of times they want you to write it right in that equation. So I just took this equation right here, and, well, we found what the constant is, so I changed k to 1/2. So now we have this one. This table of values models a direct variation, graph them, then find the constant. So I want you to do this one. So go ahead and graph it, and when you're all done, find out what k is. So go ahead, pause me now. All right, let's check it. So again, we want us to graph it 0, 0, 2, 3, 4, 6, and 6, 9. And you'll notice that you end up with a nice straight line. And that's really how it should be with the direct variation. So again, they want you to choose 2 numbers. And again, the only ones I don't want you to choose are 0, 0, because that wouldn't make sense or it wouldn't work in our equation. So I'm going to choose the point 2, 3. I could have chosen it here, or again, it's right here, 2, 3. So I chose a point on my graph, and I put in that information. Well, y is 3. I don't know what k is yet, but I know x is 2. Well, to get k by itself, I divide by 2, and I find out my constant is 3/2. So k is 3/2, but again, I'm going to put that in the original equation. So y is equal to k times x, but k is 3/2. There we go. So now we get word problems of it. We're going to write it. The number of miles Joe walks varies directly with the number of hours he walks. He walks 6 miles in 2 hours. Write a direct variation to find how many hours it would take Joe to walk 15 miles. So here they're taking it a step further. Not only do we have to find the constant, but then we have to use that to figure out how many hours it would take Joe to walk 15 miles. So we need to use the information they tell us here. And they say the number of miles varies directly with the number of hours he walks. All right, so we have really, for the y equals k times x, we're talking the constant is the number of miles or hours it takes him to go so many miles. So I just switched that so I know M is miles and H is X, or the hours. So I put in that information. Well, it takes him 2 hours, to walk 6 miles. So again, I solve for K by dividing by 2, and I find out K is 6 over 2, or 3. So again, I write that in my original equation. Y is equal to 3 times X, or if I want to keep the variables the same, I could write number of miles is equal to 3 times H. So he can go 3 miles in an hour, basically. So now we're on the second part. Use this equation that we just found with the constant to figure out how many hours would it take him to walk 15 miles. Well, 15 miles, so I know I replace M with 15, divide by 3, and it would take him, 15 divided by 3 is 5, so 5 hours. All right, and we have one more because this can be a tough concept. Your weight W on Earth's surface varies directly with your weight on Mars. A person weighing 120 pounds on Earth weighs about 40 pounds on Mars. About how much does a person weighing 180 pounds on Earth weigh on Mars? Well, then we know our weight W on Earth, so that is what that piece is. All right, it's going to be 40 of whatever the constant is. So we have to figure out what the constant is in this case. All right, so again, 40 times K is the same as 120. We divide by 40 to figure out what the constant is, and we get K is 3. So here, Y is equal to 3 times K, or X. I think I used X in the last example. It should have been K. All right. Oh, no, it should have been X. K is 3. All right. Hope I didn't confuse you there. Sorry about that. K is 3. The constant we found is 3, so I put 3 in for K. And now I have my original equation with 3 in for the constant. Now it says, find your weight on Mars if you weighed 180 pounds on Earth. All right. So again, we can go ahead and do that. Put 180 in for our weight on Earth. And then we have 3 times X. Let's figure out what our weight on Mars would be. 180 divided by 3 is 60. So you'd weigh 60 pounds on Mars. All right, final piece, writing a direct variation using a point. And it's really the same idea of what we've been doing that first time around, or really the whole night. You can use any ordered pair, so you don't have to just have a table. You could use a number on a graph to find the constant. So here in B, they say write an equation for the direct variation that includes this point, 7, -5. Well, again, we know what this is X, this is Y. So our first job is really just fill in with that constant or direct variation equation. Y equals K times X, the constant times X. So we know Y is -5. We don't know what K is yet, but we know X is 7. Well, from here we solve for K again, just like we did earlier. And we get K is -5/7. So again, last step, rewrite the equation with K. Y is equal to, the constant is -5/7, X. There we go. All right, we'll do this one together, then you get to do the last one. So again, write an equation for the direct variation that includes this ordered pair, -4, 3. Start with the equation they give us. Y is equal to K times X. Fill in what we know. Well, Y is 3. The constant is unknown, but X is -4. To get K by itself, divide by -4. And I get K is the same as -3/4. All right, you're up. I would like you to do this last problem. You need to write an equation for the direct variation that includes the point or ordered pair 3, -5. And when you're all done, let's go back and see if you have the right answer. So go ahead and pause me now. All right, let's figure out that equation. Y is equal to K times X. Well, Y is -5. K we don't know, but X is 3. To get k by itself, you divide by 3, and I find out my constant is negative 5/3. And it says write it as an equation, and I didn't do that in blue here. So y is equal to negative 5/3 x. So oops, I didn't write this one as an equation. Y equals negative 3/4 x. And again, you just start with the original up here. You just fill in what that k is. That's all we're doing. That's the change there. All right, that is your lesson. Tonight we talked about what direct variation is. Y is equal to k times x, with k being the slope or that change that happens. And we did it using a table. We did it using word models. And finally, we did this with ordered pairs. It's the whole idea of just figuring out what k is. All right, you have a good night, and I will see you all tomorrow. Adios.